Good afternoon. My name is Alex Hill. I'm with CN2 Technology. And at our company, we are focused on AR for the enterprise. Specifically, not AR for this enterprise, but the enterprise. There's an interesting thing about augmented reality. If you think about it, if you ever watched the original Star Treks, you always wondered, how is it that the guy can see that he can go into an alien ship and he can use the alien technology? Well, wouldn't AR be exactly the reason? In fact, Geordi actually wore AR glasses. So that's what I think, that's how it worked. In Scotty's case, I think it was contact lenses. So at my company, we've been doing AR since about 2012. We do a number of different types of things, from product visualization, interactive product visualizations. This is some work we did for Coca-Cola, visualizing coolers. Some work we've done on interactive technical documentation, but also product brochures. Here we're taking CAD data and putting it into an AR context. And then this is some 3D technical documentation we did for a company called Thermoplan. They have a coffee maker that you might see in a Starbucks or two. And here, this documentation is in 3D, but then when you look at the equipment itself, then you see the same documentation in that environment. Here we did some basically see-through effects where you can see through the equipment. This is we also do instructional tasks where we lead people through instructions. So here, this is to replace some manifolds in a pump. So at our company, we focus on really we try and focus on adding to the equation that which is the most valuable. This is an example of something we did for Coca-Cola on their freestyle machine. You'd be surprised, but it turns out that you have 18-year-olds who are going to be in this job for about a 1 quarter. They're in charge of a $100,000 piece of equipment, and if they don't take these things off the end of the soda dispenser, this cartridge they put in there, then they can jam the machine and destroy it, or not destroy it, but cost a lot of money. Something else we do is we try and have tasks. We try and move people through tasks. In this video, you might notice that she's going to reach down and open up the door, and if you see on the screen that it recognizes that and moves to the next task, telling her to open the next door inside. So this is sort of the holy grail of what people want to do in AR, is they want to be able to recognize the state of equipment and then have the procedures move forward. These are some more examples here involving the freestyle machine. Here, validating that somebody has done something. So in this case, they're supposed to move this thing next to an RFID reader, and ironically, we're sort of determining that yet again in AR that they did it. And here are those, these are the foils that if they don't get removed, and or if we spot them on there, then we highlight that, because this is a big no-no. So we use primarily game engine technology. The reason we use game engine technology is because When I got into this business, I realized that I didn't want to be a company like Matayo, who was supporting their own rendering. And so if somebody came along and they wanted particle features, etc., well, they were going to have to develop that. And I didn't want my engineering effort to go into something like that. So we use Unity primarily, but we are poised to use the Unreal Engine if push comes to shove. It all depends on our relationship with Unity. But Unity Game Engine has a huge market share, millions of registered developers, and the really nice thing here is that it's highly optimized for iOS and Windows, and also Android. So we can basically publish to one platform with one click, and that's really nice. So we have a platform that has AR-specific features for handling parts, transparencies, animations, exploded views. Also diminished reality techniques like what you saw on that pump, where the reason that the visual effect looks reasonable is that we've occluded what it's on top of. So we sort of hid the rest of the pump. That's called diminished reality. And we keep track of state transitions, and we have a dynamic labeling engine. And we also handle some instructional content. So our platform is basically built upon game engine technology and computer vision engines. And computer vision is, a lot of people talk about computer vision, and a lot of people are excited about it, but it's really, I would use the analogy of GPS. I don't think you would want to have to develop GPS, but you're glad that you have it. And it's really something that is probably going to end up built into game engines. I mean, not game engines, sorry, but platforms like iOS, Windows, Android. It will be something that's inside the phone, just like GPS. And that means that people who are developing augmented reality are really adding something in between the tracking and in between that and the rendering. So we have sort of adapters to numerous tracking engines, and we use different tracking engines depending on what the particular circumstance is. For instance, certain tracking engines have a really difficult time. Most tracking engines have a real difficult time with reflections. Looking in the mirror, seeing chrome, things like that. But as it turns out, Vuforia's implementation of their extended tracking happens to work quite well in the environment. I don't particularly know why, but it does. So we have analytics on top of tracking engines because tracking engines tend to say, I'm tracking, but then they're broken. And then they're tracking again, and then they're broken. So we monitor the qualitative or quantitative statistics of the tracking engines to see whether they're getting jittery and determine whether we need to move on. We need to maybe indicate to the user that it's time to prepare for tracking to break down. So our platform allows us to import assets, different types. This is very common. And we can also bring in unstructured data through RESTful API similar to parse, if you're familiar with that. We have a RESTful API for our mobile devices that allows us to do pre-caching and allows us to do, of course, online updating, but we do offline database caching, offline recognition, offline tracking. What this means is that we're very focused on customers that can't rely on going to a cloud-based solution for tracking. So some of the tracking solution providers, such as Ketchum and Vuforia, very focused on cloud, but a lot of our customers would prefer that they can be out in a manufacturing environment and recognize things. we can develop customized interfaces quickly with our system, and we also generate analytics. We have our own analytics engine that we built from the ground up, mostly because what we want to do with analytics is we want to allow for, if you've heard of funnels in mobile analytics, this is people taking two different paths through your application. One path might lead to a sale, and the other one might not lead to a sale. So we want to do the equivalent for AR, where we basically we track the user as they're interacting with the AR content, and then we are developing pathways that people take. Some people take this pathway, some people take that pathway, and so that we can analyze those pathways and help to refine the instructional content so that the people who end up calling help support, those pathways get pruned away, and the people who have successful, fast usage of the technology, those get reinforced. Excuse me. So our platform is multi-tenant, and we have a great deal of access control. We also connect to external databases through what we call external extract, transform, and load. And we also take data from CAD systems. The way we take data from CAD systems involves translation. I gave a talk earlier this morning where I talked about how what to do if you want to get CAD data into AR applications. And there's really two different worlds there. You'll have to excuse me, I'm going to switch between presentations. That didn't work very well. Just a sec. Okay. So when you're dealing with CAD data and you need to get it into an AR context, there's really a bifurcation of these two environments. One is model-based definition, where you have your CAD data and other tools that support it, perhaps rendering tools that produce photorealistic renderings, assembly sequences for work instructions, or integration with product data management that allows you to assign things like what part and how to purchase it and where to find it in the purchase system is associated with your content. On the other side of this divide is what we call traditional digital content creation systems. And this is the world of things like Maya and 3D Studio Max. And this tends to be what AR is generated in. And so between the two of these worlds, you end up having to do some sort of translation. This translation is, in some regards, it's straightforward, but in other regards, it's not. The CAD data tends to be described in parametric format. This means it's using equations to describe the surfaces. And as many of you know, when you're looking at your graphics card or a game, you're talking polygons. So this process of going from parametric data to polygons is really part of that translation to AR content. Now, why do we use polygons in AR? Because we need speed and we need efficiency, and that can't be accomplished by using parametric formats. In fact, if you're using an application like SolidWorks or something like that, and you go to look at your model, you're looking at it turning the parametric into polygons. So many things like part assemblies and instancing and coloring, they translate fairly well, but some notions like materials. Materials in a model-based definition world are things with density, things like aluminum, things like wood. But in the digital content creation world, they are shaders, surface shaders and surface texturing. So they don't translate, and you don't tend to get that data carrying across. And things like assembly sequences, which may get created in the CAD world, there are rarely tools that allow you to get that data into the DCC world. So what I want to say here about this subject is that when you can export data out of CAD directly, and you end up with things that are DCC content, like materials, polygons, things like that. But you're going to have, if you want photorealistic results, you're going to end up having to do some manual labor on it, some surface texturing, some surface shading. Because the rendering tools in the CAD world are designed really to create images and video, not to generate downstream content for digital content creation. There's a number of ways to approach this problem, and involves translation from native CAD data into digital content, DCC formats. And the CAD companies don't have an investment really in having their export keep all of their data. So you really have to go to third parties to get good translators, third parties who get their money by translating things well. And that way you can get you can get the features downstream. So if something was rendered in the CAD environment and you want to see it in AR, you have your best chance by using these third-party translators. So in this context, what happens is that you can decide how much you want the polygons reduced, and you can also decide how you want level of detail to be created. So you can have multiple levels of detail created, low resolution up to high resolution. Also, these tools have defeaturing tools which allow you to remove certain things like what are called chamfers and fillets and round holes. This can be useful for reducing the complexity, but it can also be useful for preserving IP. That this way it's harder to reverse engineer it if you don't have all the data. So for electronic interactive training manuals, you would like to get assembly sequences through this translation engine. And again, assemblies typically only generate images or videos in the CAD world. And so this is really the holy grail for CAD data, is to be able to get assemblies that are created in the CAD systems into DCC environments. And then finally, for something like field service documentation, examples where you want to go into the field and you want to be able to access parts and order those parts, you need some connection to what's called a PLM system that has a product database management component. And some of these PLM systems they have to deal with multiple CAD environments. So many companies like a GE or a Westinghouse, they've purchased other companies or had products that were developed with different CAD vendors, so they have to support multiples. And so these PLM systems help them coalesce those and work with them together. And they can export things like OpenJT, which is an industry-wide standard that preserves a lot of data, and multiple formats can reside in there. So a takeaway in this regard is that it doesn't scale very well to manually create your AR data. But it really depends on what you're doing with that AR data. For proof of concepts, we tend to do the manual work. And if it's an environment where you don't believe that the data is going to be changing very often, this may make economic sense. But really, it's a sort of a garbage in, garbage out situation, because you have to work with the enterprise partners and make sure that their digital, their model-based developers export things properly. So you have to develop workflows to make sure that they don't leave data behind. Not only are the exporters not that good, but the people exporting, I guess they're the exporters too, they need to be tuned and trained to make sure you get the most data downstream. So that's why I advocate for these translation engines. I'm going to switch back here. So our platform includes this CAD component. And it also has a content studio. Content studio allows for bringing in this content, whether it's from a CAD system or from a DCC system, and you can manipulate you can size it, arrange different models in it's a cloud-based, web-based studio environment. This is zero configuration, so that means that it is based on WebGL technology, and as a result, your user base doesn't need anything installed already on their computer. It works in Chrome, Firefox, etc. So as I was saying, materials don't really translate all that well from the model-based definition side over to the DCC side. So often if CAD data comes in, you're going to want to add some coloring to it. Or if you have colors, you may want to add some materials for it. So we have materials that you can apply there in the authoring environment. And then we also have traditional 2D UI elements that you can create, labels. And then we have a dynamic labeling engine that lets us take these labels and move them around so that they don't occlude content. So in an AR environment, it's important that you don't occlude what you're looking at, so you want to keep the content off of it. So you may not be seeing the model per se, but we use the model to keep the labels off of it. I hope that makes some sense. So our company develops we have a generic browser technology that pairs up with our studio technology, and we can filter content based on geospatial, and we can preview it instantly. So I'd like to show you an example of the system here. So this is the platform here, and I'm going to use an example here. So this is the analytics engine here with the dashboard. Then we have our content. This is basically the CMS portion. Oops. Okay, I apologize, but my computer just died on me. I think that's the end of the demo and the talk. So I was just going to show you the platform there, but that's the end of my talk.
All right. Thank you.
What can I say? Thanks.
Nothing like a battery to wrap things up, right? So we have time for a couple questions. Uh-huh.
Well, what you're still talking about is one way, though. Um, if that, dealing with downstream event, uh, downstream updates is really important, and clients are always asking us about that. And that's what I tell people to watch out for or to ask for, because if somebody changes the model upstream and we are automatically generating content downstream, if somebody has authored something, we want to be able to put that, we want to keep the labeling or whatever content they've put right there on it. In practice, I'd like to say that we have that nut cracked, but in practice it's really challenging, because what happens is that often the modeler might delete the whole part and copy paste another one, and the name gets subtly changed, and what appears to you to be the same data comes downstream looking to our system like different data. So it's a challenge, but when it comes down to things like PLM data updating, etc., a lot of times what we do is, PLM systems can often easily translate their data into something like JSON, and so we use our APIs to bring that data into our platform that way. So in that regards, they initiate changes in their PLM system, they export it to our platform, and then it shows up there in the AR content. Now, frankly, this is still one way to AR, and as far as going back the other direction, I can't think of any situations off the top of my head where we're doing anything back, but I think in a perfect world, if you create, let's say, work instructions in our platform, and then you would like to get that data back into other platforms, when you bring in something like Cortana, which is a very useful tool that a lot of companies use to create work instructions, you'd like to get it back. Our description languages can be translated and probably sent back that direction, but I don't think that's not a routine situation.
Hi.
Hey.
So our company is already doing some of what you're talking about with SolidWorks, where we want to get the parametric data into the rendering systems,
Right.
in our case lately the HoloLens, and we have encountered that scenario where you want to take the parametric data and you can just export it in something like Obj, but it doesn't contain any sort of materials, it doesn't contain any images, it's
Right.
just a flat empty model. So how does your system help you with things like the UV mapping to make it more visual?
Well, so somewhat to repeat, SolidWorks, for instance, OBJ is people will always direct you towards OBJ, but that's mostly because it's a common denominator that all systems will export to, but that doesn't mean that it's a good export option. So if that just leaves you pretty much with mesh data. So there are other formats that you can try that I imagine you've played around a bit, but if you're getting into, I know that HoloLens uses Unity for some applications, so you might try DXF and some of the other ones that's one way you can go. But as far as our approach is to take the SolidWorks files and use a third-party converter. Like I was saying, SolidWorks isn't invested in making sure that their UV mapping, etc., and textures make it to those formats, because it's a lot of hard work. So we use the example I was using there was when we were using Spatial's interop system, but we're currently using Okino's Polytrans. And this Okino is a company that's very focused on just translation, and so that's their core business. So making sure that the UVs make it to the other end, we usually go for FBX, which is one of the most solid, and we also do 3DS. But yeah, so that's what we use. We use third parties, and I think it's worth the money because they're really not that expensive, especially for that product. I think you can get their full package for under $1,000.
Great. All right, a round of applause, please.